Hello, so this is the first part of a video series on sequence and series. In this video, we go through the introduction and some formula and its derivation. So what is a sequence? A sequence is a list of numbers that follow a certain pattern. So what do I mean by that? So if I write some numbers down, if you can see a pattern in it, then it is a sequence. For example, the list of even numbers is a sequence because we can see a pattern there. You can see that? So there's a pattern. So which means for you to get the next term, this is called the first term. Then this is the second term. This is the second term. Third term, and so on. So for you to get the second term, you add 2 to the, so this first term, that gives you the second term. For you to get the next term, which is the third term, you add 2 again to the second term. So this is a sequence because you can see a pattern there. When you keep adding 2, you get the next. So in this kind of sequence, it's because there's a common difference. You can see that the difference between the second and the first is the same as the difference between the third and the second, and is the same as the difference between the fourth and the third. So it's constant. So because that difference is constant, so we say that this kind of sequence is called an arithmetic progression. So we'll talk more about arithmetic progression in a minute. So what is important here is that there is a sequence of numbers. You have a list of numbers and you can figure out a pattern. So sometimes the pattern might not be constant. For example, if you have this 2, 3, 5, 8, if you look at the pattern here, for you to get the next, you add 1. For you to get the next, for you to get the third term, you add 2 to the second term. For you to get the fourth term, you add 3 to the third term, and so on. You can see the pattern here. You increase the difference here by 1 for you to get the next. So this is also a sequence, but it is not an arithmetic progression because the difference is not the same, it's not constant. Okay, so that's you can have arithmetic progression. You can have also geometric progression. So those are the unique, or I can say those are the common kinds of sequence that we are interested in. The arithmetic progression when you have a common difference, and geometric progression when you have a common ratio. That's what we call it. So arithmetic progression called AP. So you have arithmetic progression when there's a common difference in the sequence. There is a common difference in the sequence. So just like the sequence I gave the other time, 2, 5, 8, 11. Now this one, there's a common difference of 3 because for you to move from 2 to 3, you add, from 2 to 5, you add 3, from 5 to 8, you add 3, from 8 to 11, you add 3 again. So this is an arithmetic progression with a common difference of 3. Okay. Now, in arithmetic progression, this first number here has a name. We usually call it the first term, A. You notice that's A, the first term. And the common difference that I talked about is denoted as D, common difference. So that common difference, D, is you obtain that by finding the difference between any pair of terms, any like consecutive terms in in the sequence. Like if I choose the first and the second, so the second term minus the first term should give me the common difference. And this is also equal to the third term minus the second term. This is also equal to the fourth term minus the third term, and so on. Okay, that's B. Then there's another thing that is common to arithmetic progression or the sequence in general is n. So this n is the number of terms in the sequence. Number of terms in the sequence. Okay, so if I know, let's say the first term is denoted as A, the second term as D, and the number of the common difference as D, and the number of terms as N. So if I write, 10, let's say I have terms and N, the first term, A, that is when N is 1, and the second term, when N is 2, you have the second term, and you obtain that by adding the difference. Just like here, you add 3 to the first term to get the second term. So to get the third term, you add 3 again to the second term. So that means you have A plus D again. So that means that will give you A plus 2D. That's for the third term. Then for the fourth term, you had D again. So that gives you A plus 3D. So because you add the difference each time, you move from one term to the next. Now, this is for the fourth term. So if you look at this, you've seen a pattern here. That's when N is 2, D, you have 1D. When N is 3, you have 2D. When N is 4, you have 4D, which means for any particular term at a particular position, N, I can determine the nth term of that sequence. So UN, that's the term at a particular position, N, will be equal to the first term, A, plus, because when N is 3 here, D, you have 2D here. So that means if I subtract 1 from N and multiply it by D and add A to it, that gives me the term in that particular position, N. So that will be N minus 1, D. N minus 1 because when this is 2, this is the coefficient of D is 1. When this is 3, the coefficient of D is 2. And when this is 4, the coefficient of D is 3. So which means if I subtract 1 from N, I get the coefficient of D, which is this. Okay? So this is the formula for obtaining the nth term of an arithmetic progression. Okay? So let's look at some examples. So the question is, find the 20th term of the arithmetic progression 2, 5, 8, 11. Write the formula for the nth term. Okay? So how do we solve it? Here we have to find the 20th term. 20th, that means we know N as 20. That's the position that we are looking at. Then we have the AP, the arithmetic progression. Here you can see that the first term is 2. A is 2. And we can, because we know that it is an arithmetic progression. So we know that it will definitely have a common difference. So D, which is a common difference, will be the second term, 5, minus the first term, 2. I can also use the third term minus the second term. I'll get the same thing. So that will give me 3. So I know that the common difference is 3. The first term is 2, and N is 20. So I can determine the 20th term because I know that UN is A plus N minus 1 D. Now I know A as 2, I know N as 20, I know D as 3. I can determine U20. U20 will be A2 plus 20 minus 1 times 3. So U20 will be 2 plus 19 times 3. So, and U20 will be 2 plus 19 times 3 should be 57. So which is equal to 59. Okay, so that's the term at the 20th position, which means if I continue to write this sequence, these 2, 5, 8, 11, if I continue, then 2, 5, 8, 11, and the common difference is 3. If I add 3 to this, I get 14. If I add 3 to this, I get 17. If I add 3 to this, I get 20. If I continue like that, when I get to position 20, then I'll get 59. So that's what it means. So it is a way of figuring out the number at a particular position without writing out, without listing out all the terms in that sequence. This is powerful. So if I want to get the term at 100th position, I don't have to write all this. I don't have to write these numbers up to 100th position. I will just substitute n as 100 here, and a as 2, and d as 3. Then I will know exactly the number that falls at this position 100. Okay, so that's our arithmetic progression work. Then for geometric progression, we said that a GP, a geometric progression, we have a common ratio. Geometric progression. A sequence with a common ratio is called geometric progression. Progression as GP. So what do I mean by that? By common ratio. So which means if I have, let's say I have a sequence just like this, 2, 6, 18, and so on. Now this is a GP, a geometric progression, because this one does not have common difference, because if I subtract 6 minus 2, that gives 4. 18 minus 6 is 12, so it's not constant. But I can check whether it's a GP if I do the ratio. The second term divided by the first term, does it give me, is it equal to the third term divided by the second term? So if this is correct, then we know that, oh, this is a geometric progression. So this will give us 3, and this will also give us 3. That means the ratio is common to them. This divided by this is 3, this divided by this is also 3. If you continue like that, you also have 3. So that means you have become a geometric progression there. So now for a geometric progression, let's say you have the terms, the first term, when n is 1, u1 is a. And the second term, u2 will be, for you to get c, what you do basically is to multiply the first term by the common ratio r. And if I want to get the next one, I multiply 6 by r, the common ratio 3, which is, that will give me 18. So that's how I continue. Then for the second term, I will multiply a by r. So this is a, this is ar. Then for the third term, tell me when n is 3, then I will multiply the second term, ar, by the common ratio again, and that gives me ar squared. So if I want to get the fourth term, then I will multiply the third term by the common ratio again. That gives me ar raised to power 3. Can you see a pattern there? So when n is 4, the power of r is 3. When n is 3, the power of r is 2. So that means you subtract 1 from n in order to get the power of r. So when n is 2, the power of r is 1. Then this should be 1, r is 1. So it means that I can write the equation for the nth term of a geometric progression as ar raised to power n minus 1. So this is the formula for determining the nth term So that means the term at a position n, at the particular position that you are looking for, then is equal to the first term multiplied by the common ratio raised to power the n, you're looking at that position, minus 1, the n term of a geometric progression. Okay. Now, let's look at an example on GP. So the question is, given a geometric progression GP 2 minus 6, 18, and so on, find A, the common ratio, and B, the 10th term. Okay, so what do we do? Now we are told that is a GP, so we don't need to check. But if we are not told that it's a GP and we have to check whether it's a GP, we just check if we have a common ratio. This divided by this, is it equal to this divided by this? If it's equal, then it's a GP. Now, but we're told that it's a GP, so I know it will definitely have a common ratio. So and that common ratio is the second term divided by the first term, which is also the third term divided by the second term. So, and that will be minus 6 over 2, which is minus 3. So I know that the common ratio R is minus 3. Now, that's the first part. Then the second part says find the 10th term. So the 10th term, UN is AR raised to power n minus 1. So the U10 will be, n is 10, because saying the 10th position. That will be A, which is 2, the first term, multiplied by R, common ratio, raised to power 10 minus 1, because n is 10, A is 2, and R is minus 3. So U10 will be 2 multiplied by minus 3 raised to power 9. So minus 3 raised to power 9 multiplied by 2. This will be quite large. So U10 will be 2 times minus 19683. So U10 should be 2 minus 39366. Okay. So that's it on the first part, and I will see you in the next video. Bye bye.